Okay, so picture this, right? Like a hacker trying to get into a power grid, and every second counts.
Yeah.
And then imagine a system that can, analyze tons of data and see that attack right as it happens, even if it's like brand new.
Wow.
That's what we're going to dig into today.
Okay.
It's called Neuromorphic Cybersecurity.
Interesting.
And we found this super cool research paper. It's called Cyber-Neuro RT, Real-Time Neuromorphic Cybersecurity, published in Proceeding Computer Science. And basically, it's about how researchers are using something called spiking neural networks to, maybe totally change cybersecurity as we know it.
That's a big claim.
So get ready. Because by the end of this deep dive, you'll understand how these systems work and why they could be a total game changer.
So what I think is so fascinating is that these systems, they're actually modeled after the human brain.
Oh, wow.
Using a type of computing called neuromorphic computing.
Okay.
And it actually goes, beyond normal AI, right? By, taking inspiration from the structure and
The function.
the function of the brain.
So cool.
Yeah.
Okay, so let's break this down a bit, right? We know that high-throughput environments like data centers
Right.
and those giant HPC clusters process a crazy amount of information every single second.
It's a lot of data.
So what makes securing them so challenging?
So think about it as a superhighway, right?
Okay.
With millions of cars just speeding by every minute.
Oh, wow.
That's kind of the amount of data flowing through these environments.
Okay.
And traditional cybersecurity tools, they work great for smaller networks,
Yeah.
but they can really struggle to keep up with this volume, this speed.
Yeah.
It's almost like you're trying to catch a specific car on that superhighway just using your eyes.
Oh, yeah.
Nearly impossible.
So how do these spiking neural networks, or SNNs, as I guess we'll call them, how do they fix this problem?
So SNNs, they process information a lot more like our brains do.
Yeah. Oh, okay. Using these pulses of electricity, kind of like spikes, yeah, instead of those typical ones and zeros that computers use, right? And this lets them be a lot faster and way more energy efficient, especially when dealing with all that data.
So it's they just have a better way of processing all that information.
Yeah, exactly.
Making them better at spotting those speeding cars, as you put it, on the data superhighway.
Yeah, they're more attuned to the traffic patterns.
So the paper actually focuses on this system called Cyber-Neuro RT. What were they trying to do with this system?
Well, they wanted to see if those SNNs could work in a real-time cybersecurity system for these huge high-throughput environments.
Okay.
So to test this, they trained a deep learning network on a huge data set, over 450,000 entries.
Wow.
From Zeek logs,
Okay.
which are commonly used for network security monitoring.
Okay. And these log entries had both normal network activity and 8 different types of cyber attacks.
Ah, so it's they're showing it at all these examples of good behavior and bad behavior,
Right.
so it can tell the difference.
Yeah, kind of train in it, right?
So this data set, where did it come from?
It's adapted from the UNSW dataset, which is this gold mine for cybersecurity research.
Oh, okay.
It covers a really diverse range of sources, those little internet-connected sensors we see everywhere these days, to Windows and Ubuntu systems, and even just general internet traffic.
Oh, wow.
And this variety is super important because it helps the system learn how to find threats in a lot of different contexts.
Yeah, I mean, that makes sense. It's like training a detective, right?
Right.
On all these different crime scenes, so.
Exactly.
But I'm sure it's not just about, how much data there is.
No,
right?
no,
The quality has to matter, too.
Absolutely. Yeah. One of the challenges that they pointed out is the data is really imbalanced. 2/3 of it is normal traffic.
Oh, okay.
So the system has to be extra careful not to just label everything as safe.
Yeah.
So to make sure it was learning correctly, they focused on these key features of the data, like the source and destination, IP addresses, ports, connection states, the things that are often really telltale signs of
malicious activity.
Yeah.
So basically highlighting all the important clues.
Exactly.
Right, for the system to pay attention to.
It's all about focusing on the right signals and all that noise.
So we've been talking about this deep learning network.
Mm-hmm.
How did they get that to work on these special neuromorphic chips?
That's a great question.
It sounds like translating, from one language to another.
You're exactly right.
Okay.
They actually tested it on 2 different platforms, Intel Loihi and BrainChip Akida,
Okay.
which are like 2 of the leading companies in this field. And this process of like going from the language of deep learning to the language of these spikes,
Yeah.
it involves something called quantization.
Quantization.
Yeah.
Okay, so is that like...
Think of it like
Yeah.
compressing a large file, right? To make it smaller and easier to like work with,
Yeah.
but in a way that still keeps the essential information.
Gotcha.
So they tested different levels of compression using like 4-bit and 8-bit precision to see how it affected the system's performance.
So this all sounds incredibly complex.
It is.
Are there downsides to using these chips?
Well, one of the big challenges is keeping that accuracy while still making it work for, these different platforms.
Yeah.
It's still early days for this kind of computing, so there are like definitely hurdles to overcome.
It sounds like they're really pushing the boundaries of what's possible in cybersecurity.
They really are.
So I'm really curious to hear how well these SNNs performed. Did they live up to the hype?
So this is where it gets really exciting.
Okay.
Both the Intel and the BrainChip implementations, they actually achieved similar accuracy, especially when they were using the higher 8-bit precision.
So even though they're using a totally different way of computing, they're getting similar results to like the traditional methods.
Exactly. And what's really impressive is Intel's 8-bit model matched the original network's accuracy of 93.7%.
Wow.
Which is huge.
That's amazing.
Yeah, because it totally blew past that 66% accuracy you'd get, just by chance with the data being imbalanced like we talked about.
Yeah, yeah.
So this means the system is actually like learning how to find those threats. It's not just making, lucky guesses.
So that's a really great sign.
Yeah.
What about efficiency though? Was there any improvement there?
Oh, yeah, definitely. Converting to SNNs really reduced the model size from almost 20 megabytes down to just over 6.
Okay, why is that so important?
Well, think about all those internet-connected devices we talked about, right? Those smart thermostats and security cameras and industrial sensors. They don't have a lot of processing power and memory.
So a smaller model means you can actually use this tech in those more, I guess, limited environments, right?
Exactly. It's one of the biggest advantages of SNNs. They can bring really sophisticated cybersecurity to places that, just couldn't handle it before.
Okay, so we've got the accuracy, we've got the efficiency. What about speed?
Right.
How did the SNNs do there?
So unfortunately, directly comparing processing speeds was a bit tricky because we were using simulations for BrainChip and the Intel Loihi was actually running on hardware.
So it's hard to really compare, which is faster because the environments are so different.
It's tough to make a fair comparison, but even with that, they did see a lot of potential for speed improvements with SNNs, which is really encouraging.
So it's like they're showing that it's possible, but they still need to kind of work out how to make it faster in the real world.
Yeah, they're laying the groundwork.
Okay.
And speaking of making things better, they actually didn't just stop at converting the model.
Oh.
They wanted to like fine-tune it, for even better performance.
So they were trying to get every little bit of speed out of it without losing accuracy.
Yeah, they called it design space exploration.
Okay, so what did that involve?
Well, they tried things like adjusting the sensitivity of those artificial neurons to those incoming spikes.
Okay.
You can think of it as like making them more or less responsive to certain signals.
Okay.
And they also tried this thing called an early exit strategy where the system can make a decision faster if it's already pretty sure about what it's seeing.
So it's like if it's 99% sure it's seeing an attack, it doesn't need to keep
waste time
analyzing the data.
Yeah, it can just sound the alarm.
It can just raise the flag.
Exactly.
Did these optimizations actually work?
They did. Yeah, they were able to reduce the number of steps that the system needed to make a decision, bringing the average down to 106.
Wow.
From 290.
That's a pretty huge improvement.
It is.
Okay, so it sounds like they're making some really good progress.
Yeah.
Making these systems faster and more efficient.
They're not done yet. There's a lot more to do. Testing on even bigger and more diverse data sets and experimenting with different optimization techniques.
So Okay, we've covered a lot of technical stuff here.
Yeah.
Let's take a step back and recap.
Okay.
We've talked about the challenges in cybersecurity, especially with these really high throughput environments,
Right.
and how the traditional methods sometimes can't really keep up.
Mm-hmm. They just can't keep pace.
And we've also seen how these spiking neural networks could be a more efficient solution.
Right. They process information more like our brains do, right?
Right.
Which makes them faster and more energy efficient.
And the research showed that they can be just as accurate as traditional deep learning, but with,
Yeah.
a much smaller size.
Significantly smaller, yeah.
It's cool to see how they took those theoretical benefits and made them into real results.
It's really exciting work.
Yeah, it's a real testament to the researchers in this field.
Absolutely.
So we've been focused on all the technical details,
Mm-hmm.
but how does this all fit into the bigger picture of cybersecurity? How might this technology really change the game?
Yeah, that's a great question.
I think that's a perfect place to pick up in part 2.
Sounds good. It really could change things, you know?
Yeah.
The way we do cybersecurity now is kind of like trying to plug holes in a dam, right?
Okay.
Constantly reacting to new threats and patching vulnerabilities.
Yeah.
But with this neuromorphic computing,
Yeah.
we might be able to build a system that's smarter, more adaptable, one that can learn and evolve
Oh, wow.
to stay ahead of the attackers.
So it's almost like going from, being on defense
Right.
to being more proactive.
Exactly.
And instead of just reacting to, attacks,
Mm-hmm.
we're anticipating them,
Yeah.
stopping them before they even,
Yeah, before they happen.
and that's got to be even more important as these attacks keep getting more complex, right?
Oh, absolutely. Yeah, we're seeing way more connected devices,
Right.
which, opens up more ways for them to attack.
Yeah.
And the attackers are getting more sophisticated too.
So this tech could be super important for protecting not just those, big high throughput places we talked about,
Right.
but all those devices we use all the time.
Absolutely. Think about the Internet of Things.
Right.
Smart homes and wearables and sensors, even self-driving cars.
Yeah.
All these things are generating tons of data, and they all could be entry points for attacks.
It's kind of mind-blowing
It is, yeah.
to think about.
Mhm.
But it sounds like these SNNs, they could really help, right?
Yeah, they could be a key part of the solution
Right.
because they're so efficient.
Right.
They can be used in a lot more places,
Yeah.
including, places with not a lot of processing power or memory.
Right. Like those
Yeah, like those tiny IoT devices.
Okay.
So we can actually start building security right into those devices
Oh, wow.
instead of relying on just those centralized systems that get overwhelmed by
Yeah.
all the data.
So that's a huge change in thinking.
It is. It's a big shift.
It's like giving each device its own little
Yeah.
cybersecurity brain.
Yeah, kind of. Like
Right.
a little bodyguard for every device.
And since these SNNs, learn and adapt,
Right.
they can potentially spot threats that haven't even been seen before.
Exactly.
That's so cool.
Yeah, it's not just about recognizing those known attack patterns anymore.
Right.
It's about having these systems that can learn from all that data and find those weird things that might be a new type of threat.
That's cybersecurity intuition.
Yeah,
Yeah.
exactly.
Right.
And the researchers even mentioned they could potentially be run on GPUs.
Oh, really?
Yeah.
Why would they mention GPUs when we've been talking about,
Yeah.
specialized neuromorphic chips?
It's more of a practical thing.
Okay.
They know not every organization has the money or the need
Yeah.
to invest in that special hardware right now.
So they're basically making the tech more accessible,
Exactly.
even for those who might not be, on the cutting edge.
Right.
That's great.
It also kind of shows that those algorithms and
Yeah.
techniques that they develop for these SNNs, they can often be adapted to work on, more typical hardware too,
Okay.
which opens up even more possibilities.
It sounds like we're really close to a big change in cybersecurity.
I think so, yeah.
But, just like with any new technology,
Mm-hmm.
we have to think about the good and the bad.
Absolutely.
Right.
Yeah.
So what are some of the things that still need to be figured out?
Well, one thing we've already mentioned is
Yeah.
how hard it is to compare performance across different platforms.
Right.
As long as we're using simulations for some things and actual hardware for others,
Yeah.
it's hard to really compare them directly.
So we need better benchmarks in testing.
Yeah, we need more standardized ways to measure how these different systems stack up.
Okay.
And then, of course, we got to make sure these systems are,
Yeah.
reliable.
Right.
We don't want a system that's like always raising false alarms.
Yeah, that would be a nightmare.
Right. It would be, people would just start ignoring the warnings.
Right, totally.
So we have to make sure they're accurate and reliable.
Hmm.
But we also have to think about how they'll fit in with
Yeah.
our current cybersecurity stuff.
Right. It's not just about the tech, it's about the people using it too.
Yeah, exactly. How do we train people to use these systems effectively?
That's a great question.
Some experts think we need to come up with totally new training programs and skill sets.
Oh, wow.
Yeah.
So it's not just about understanding, how they work technically.
Right.
It's about
It's about being able to interpret what they're telling us, knowing how to troubleshoot them and how to integrate them into our existing security stuff.
So maybe it's not about getting rid of jobs.
Right.
It's about changing them.
Yeah.
Right. We need people who can kind of bridge that gap between the tech and the humans.
It's a really interesting evolution of the role.
Yeah.
You could think of it as going from being like a cybersecurity firefighter,
Okay.
always reacting to the latest thing, to being more of a cybersecurity architect,
I like that.
building these smarter and more, resilient systems.
Yeah, that sounds a lot less stressful.
Probably.
Right.
But it does mean that we'll need new skills,
Okay.
right? Understanding how to train these SNNs,
Mm-hmm.
how to evaluate them,
Yeah.
how to interpret what they're saying.
It's like any new technology.
It is, yeah.
We have to adapt, right?
Mhm.
Learn new ways of working with it.
Absolutely.
It makes you wonder what kind of training programs and certifications there'll be in the future.
It's an exciting time to be getting into the field.
Oh, yeah, for sure.
And it's not just about those technical skills, right? We also
No.
have to think about the ethics of it all.
Yeah, you're right. It's easy to get caught up in the cool tech stuff and forget about the bigger picture.
Right? As these systems get smarter,
Yeah.
how do we make sure they're being used,
Right.
for good?
Responsibly and ethically.
Yeah,
That's
exactly.
a question we can't ignore.
We can't.
One concern is bias, right?
Right.
Just like any AI,
Yeah.
these things are trained on data.
Yeah.
And if the data is biased,
The system can be biased too.
right, so it's like any tool,
Yeah.
right? It can be used for good or for bad.
Mhm.
So we need to be careful
Absolutely.
about, what could happen and make sure it's not misused.
Transparency and accountability are going to be really important.
Yeah.
We have to understand how they make decisions,
Right.
and make sure there's human oversight to prevent,
Yeah.
unintended consequences.
It's almost like we're creating this black box
Yeah.
that we don't fully understand,
hmm
even though it's making these huge decisions.
That's a valid concern, and
Yeah.
researchers are working on it,
Okay.
trying to develop ways to make them more transparent and explainable.
That's good to hear.
Yeah.
So it sounds like there's a real effort to do this right,
There is.
ethically. This tech has the potential to be
Yeah.
really disruptive,
Mhm.
both in good ways and maybe some challenging ways.
Right. It's like opening a door to this whole new world.
Yeah.
With tons of opportunities, but also some unknown risks.
You've brought up a lot of really interesting stuff.
Well, thank you.
So before we wrap up this part,
Okay.
I want to go back to something you mentioned earlier, that ability to learn and adapt.
Right.
It's one of the most fascinating things about this technology,
It is. Yeah.
but it also raises some interesting questions.
Definitely.
So the researchers, they mentioned exploring techniques like
Yeah.
spike timing dependent plasticity or STDP.
Right.
I don't know about you, but I'm having a hard time wrapping my head around STDP.
Yeah. It's a mouthful for sure.
Can you explain that in a way that even someone like me who's not, a neuroscientist can understand?
Sure. Think of it like this. Imagine you're learning a new song on the piano. At first, your fingers are all over the place, and it sounds kind of clunky.
Mm-hmm.
But the more you practice, right,
Yeah.
the stronger those connections between your brain and your fingers get.
Oh, yeah.
And eventually, you can play it smoothly without even thinking about it.
So you're saying STDP is kind of like practicing for the SNN?
Yeah, exactly.
It gets better at
Right.
recognizing patterns?
It strengthens those connections between its neurons based on when they fire.
Right.
And it gets better at recognizing patterns.
So it's like cybersecurity intuition.
Yeah, exactly.
It's not just reacting to, known threats anymore.
Right.
It's about having a system that's always learning and adapting.
Mm-hmm. And the researchers even mentioned exploring unsupervised or semi-supervised learning, which means the system could learn to identify threats without being explicitly told what to look for.
Wow.
Yeah.
That's pretty amazing.
It's a really exciting area of research.
Yeah.
With the potential to completely change how we approach cybersecurity.
I'm ready to dive into that more, but
Yeah.
before we do that, it's important to remember that this is all still pretty new, right?
Yep, it is, yeah.
There's still a lot of things we don't know, and we have to be careful about, overhyping it.
We've talked about some of the potential benefits, but there are risks too, right?
Right. So one concern is that they could be vulnerable to these adversarial attacks.
Right, where attackers try to trick the system into misclassifying data.
So they're basically trying to find ways to fool it, right?
Exactly, yeah.
Exploit its weaknesses.
Right, and as these systems become more complex and sophisticated, it might get harder to understand how they're making decisions, which could lead to, a lack of transparency and accountability, which is, not good.
Yeah, it's like we're making a black box
Right.
that we don't fully understand.
Yeah, even though it's making really important security decisions.
Yeah, that's a little scary, honestly.
It is. It's a valid concern, and it's something researchers are working on.
Okay, good.
Trying to develop ways to make them more transparent and explainable.
That's good to hear.
So we can understand how they're coming to their conclusions.
It sounds like there's a real commitment to doing this right.
There is, technology is never really neutral, right?
Yeah.
It's shaped by the people who create it.
Yeah.
So it's up to all of us to, have these conversations and make sure this stuff is used for good.
For the benefit of everyone.
Exactly.
That's a great point.
Thank you.
So I think we've covered a lot here.
We have, yeah.
We talked about the potential applications, the challenges, the ethical stuff.
Right.
What's next for us?
I think it's time to shift gears a little bit and talk about the people who are going to be using this tech.
Okay.
How might it change the role of the cybersecurity professional?
Right.
Right. Well, we need different skills, to manage and oversee these intelligent systems.
That's a really fascinating question.
It is, yeah.
It's are we training our replacements or our partners?
Right, exactly.
It'll be interesting to explore that in part 3.
I'm looking forward to it.
It really is a big question.
Yeah.
Are these SNNs going to, replace us?
Yeah.
Or become our new best friends?
Right. It's like a sci-fi movie or something.
Totally, where the AI takes over, but hopefully a happier ending.
Hopefully, yeah.
So where do you think it's going to land?
Well, probably somewhere in between those two extremes, right?
Okay.
Like we said, SNNs can automate certain tasks, which makes things, a lot more efficient.
Yeah.
Think about all those hours you spend, going through log files.
Oh, yeah.
Trying to find something suspicious.
That's the worst.
Right, and SNN could, take care of that.
Okay.
Which frees up those human analysts to do, more strategic stuff.
So it's like having this superpowered assistant.
Yeah.
Taking care of all the boring stuff.
Right.
So the humans can focus on the bigger picture.
Exactly.
But wouldn't we still need people to design and train these systems?
Oh, absolutely. Yeah.
Right.
You can't just plug it in and expect it to, work miracles. We'll need people who understand how these things work and what they're good at and what they're not so good at.
Yeah, and how to understand what they're telling us.
Exactly.
Yeah.
So maybe it's not so much about replacing jobs, but more about, changing them.
Right. We need people who can translate between the tech and the humans, right?
It's like a new kind of cybersecurity professional, right?
Yeah.
Think of it as going from being like a firefighter, always putting out fires, to being more of an architect, building these more intelligent systems.
I like that. That's a good analogy.
So it means we'll need new skills, new expertise,
right?
Understanding how to train these SNNs
right.
and evaluate how well they're doing.
It's like with any new technology, right?
It is, yeah.
Right? We got to learn how to use it.
We have to adapt and learn.
It's what kind of training programs,
Yeah, for sure.
That'll be down the line.
Totally.
And it's not just about like the technical skills,
Wait,
right?
no, we have to think about the ethical stuff too, like we were talking about before.
Yeah, it's easy to get caught up in all the cool stuff and forget about the bigger picture.
Right, and as these systems get even smarter,
Yeah.
we have to be really careful about how they're used.
How do we make sure they're used ethically,
Right. One of the big concerns is bias, right? Just like any AI, these SNNs are trained on data.
Right.
And if that data reflects our own biases, then the system will too.
So it's really like any other tool, right?
Yeah, exactly.
It can be used for good or for bad. It depends on the person using it.
It all comes down to intent.
Right.
And how we use them.
So we got to be mindful of what could happen, right?
Absolutely. We have to build in like safeguards, to prevent misuse.
So transparency and accountability are really important.
Super important.
Okay.
We need to know how they're making these decisions.
Yeah.
And make sure there's like a human in the loop.
Right. To prevent,
Yeah, to prevent those unintended consequences.
So it sounds like there's a lot to think about.
There is, yeah.
But it's also really exciting, right?
Oh, it's incredibly exciting.
This could change everything about cybersecurity.
I think it could. It's like we're on the edge of,
Yeah.
a whole new era.
And cybersecurity professionals are going to be right there,
Yeah.
leading the way.
Absolutely. Using these new tools.
So I think we've covered a lot of ground here.
I think so, yeah.
We went from like the basics of how this all works to like what it could mean for the future.
The future of security.
You've given us a lot to think about.
Well, it's been a pleasure talking about it.
So before we wrap up, let's leave our listener with a final thought, right? We've talked about how these SNNs can learn and adapt.
Right.
What if they get better than us?
Better than humans.
Yeah, what if they become so smart that they can see threats and respond way faster than we ever could?
Wow, that's a big question.
Right. Does that make us safer? Or does it create new problems?
It's something to think about as we, go into this new world.
That's a great point to end on.
That's a lot to consider.
So thanks for joining us on this deep dive into neuromorphic cybersecurity.
Thanks for having me.
We'll be back soon with another deep dive into something new and fascinating.
Can't wait.
Until then, keep learning and stay curious.